Hi everyone, welcome back to Global AI Community on Virtual Tour. We are about halfway through our 30-hour stream, I believe, with our 32 different speakers from all over the planet. And we're learning so much about AI. I've certainly been learning lots of great new stuff about AI. So huge thanks to everyone for joining us, and I hope you continue to watch the sessions. In this session, we are joined by Laurent. Laurent is a senior cloud advocate at Microsoft. And actually, me and Laurent are on the same team at Microsoft. So this is a right treat to be able to be the host for such a great speaker. So hi, Laurent, how are you doing?
I am doing very fine. Thank you, Amy. And how are you holding up?
Oh, very, very good. Very good. Powering through. Yeah, I think we're on hour 8 of my hosting. So this is very exciting out of 16. But no, all good. And then do you want to tell everyone where you are and what time it is currently where you are?
Yes, so I'm based in Zurich, Switzerland, or very close from Zurich, and it's 3 p.m. right now. So 3:01 to be precise, because I'm Swiss, so I have to be. And yeah, it's a beautiful day today, actually.
Oh, great stuff. Great stuff. So yeah, another country to add to the list from our speakers. So that's always great. But yeah, I don't want to take any more of your time. Really excited to hear about taking advantage of AI easily with Azure Cognitive Services. So feel free to take it away.
All right, thank you so much. Well, it's a great pleasure to be here and to talk to you about cognitive services, because I'm a developer. I'm not really an AI expert. I'm not a data scientist like you, Amy. And so for me, sometimes AI is a little bit tricky, and I definitely have, it's easier for me to work with SDKs than to work with really, AI models that I need to create from scratch, pretty much. So, that's the point, right? Machine learning is not easy. And I think that you have probably heard that a few times. We have definitely tools and services to help you do that, but it is still tricky. And when you're a developer like me and you come and you see, diagrams like this one or equations like this one, I probably did some linear algebra and all kinds of things in engineering school, but it was 25 years ago. So it's a little bit a long time. And so it's a little bit complicated for me. And if you take a line from easy to hard, if you want, you have some really hard tasks in AI, things like training a new model from scratch and really starting from zero and gathering the data. And gathering the data can be very, very time consuming, cleaning up the data. And then after that, preparing this data and training your models. And that's kind of hard. But then something which is really easy is if somebody else has done this work and put it online for you to consume as an API, for example, as an endpoint, then it's really easy. And somewhere in the middle, we also have a possibility to have some pre-trained model where you are refining the training by adding some data, for example, and then retraining them by customizing the training. And that could be, for example, the difference between facial recognition, where an existing model, a non-refined model, if you want, is going to tell you, okay, this person is a male, 49 years old, handsome, etc., right? But if you customize the training, then it's also going to be able to tell you, oh, that person is also Laurent Bugnion, who works for Microsoft, for example. So here we have a little bit of the scale. And so if we consider this scale, training a model from scratch, this is really easy. We are not going to talk about that in this presentation, but as you probably know by now, because you have seen other presentations today, on Azure, we have a lot of tools that can help you do that, things like Jupyter Notebooks integration, also a lot of support for the ecosystem, TensorFlow, PyTorch, etc. So you can totally train your models yourself. We also have a lot of services and tools. So this is a little bit the landscape of our AI platform, if you want. A lot of tools as well, but today we are going to concentrate on this so-called pre-built AI, cognitive services, and understand more about those. So we are not going to go into the hard part today. We are going to concentrate on the easy to medium part. So what are cognitive services? They are a set of APIs. They are APIs which are published online, which are accessible via REST endpoints, and they harness pre-trained machine learning models so that you can add that to your application without necessarily understanding all the implication, all the intricacies, I would say, of AI. So it is quite convenient, especially for developers. So cognitive services will allow you to do that in 5 different domains. I would say vision, things like custom vision, face recognition, emotion recognition, speech, speech to text, text to speech, etc., language recognition, and also in the domain of decision and search. And here we have a little bit more complete view, if you want, of the services we have. So things like Video Indexer is a great service. For example, you can upload your video or even just some sound, and then it will give you a transcript. It will give you some analysis also on how many speakers there are. It can even, if you customize the training, it can even tell you who is speaking at the moment. And then it's going to give you all kinds of information on the video and keyframes and things like that. Computer vision, we have tons of services. We are going to show you a little bit later a demo of image classification, but we also have the facial recognition. We have forms recognizer, which is a great service that you can use if you have a bunch of PDFs and then you want to make sense of those PDFs and extract the information. Ink recognizer for handwriting, things like that. We have speech, also speech to text, text to speech, translation in multiple languages. I think we have more than 60 languages at this time. We have language understanding, the LUIS service, which is really cool because it helps you really make sense of a text. Translator, we also have all kinds of services which help you making sure that a particular resource, a video or a soundbite or a text, is actually suitable for children, for example, these kind of things, or suitable for work for that matter. Anomaly detector, which is going to allow you to analyze a set of data and check if there are some anomalies inside that. So by clustering and all the intelligent search that you can do. In the decision, we also have, in the language, we also have the Q&A maker. This is an interesting service where you can point this service to your frequently asked questions on your website, and then it's going to extract information from that and do a bot. And this bot can be integrated in services like Skype, for example, or other chat infrastructure, and it's going to be able to answer questions in a natural language. For example, if you say, is your shop open at the moment? The bot is going to be able to check the opening hours in the frequently asked question and then answer yes or no, the shop is open. So make sense of natural language. So a lot of very, very interesting services. And this allows you to create applications like, for example, this one. This is basically multiple services which are chained together because it's often the best way to make sense of the information. So here, suitable in times of working from home, you have people here in the meeting room, it so happens, but it could be just from home with video recognition. The service is able to say who is on the video at this time. It's able to do a transcription as well, which is great for, when you miss a meeting and then you want to check the recording later. It's also able to say who is speaking right now, and it's even able to extract notes. So that's interesting because it can, for example, check what is the keyword in each sentence and maybe extract important information. It's also able to translate in real time in different languages. So if you have multiple people around the world, that can be really, really interesting. So this is just, a short demo, if you want, a short example of what you can do. But really, where do you want to get started, and how can you, learn about those cognitive services? And so one possibility that you can do is go into our portal. This is azure.microsoft.com/services/cognitive services. And here you have a description of the services that we have. So if you scroll down, you're going to see the different categories that we have, as you can see. And for example, let's go into vision and let's check the facial recognition. So I'm going to click on face. And if I go down a little bit, there is an example. You can try things directly in the portal here to understand what those are returning. You see, this is some JSON. I'm going to change the model to have more information here. And so you see, we are really getting a lot of information from the service. Things like, where is the face of this person? Is this person bald? Well, she's obviously not. A hair color, and notice that we We have information about is the hair brown, 99% confidence, black 57% confidence, red, etc., etc. So this is typical from AI to return this kind of information. The position of the head in the 3D. Does this person has makeup? Does she have facial hair? She obviously doesn't. Emotions, also here we see she's 100% happy. This is great. But we also analyze for anger, contempt, disgust, fear, etc., etc. So tons and tons of information which is returned to you by a simple API call. Now, we also are able, of course, to treat custom images. So I'm going to take an image from a team dinner that we had a few years ago, a couple of years ago. And here you see that there are multiple faces on the picture. And some of those faces are quite far. They are quite small. So this is myself. It says I'm 41, which I love. I was actually older than that on this picture, but it doesn't matter. It makes me happy, which you can see on the picture. Here we see another person next to me, my colleague Ruth here, 26. I think she will be happy to read that as well, probably. But anyway, Anthony here, who spoke to you, I think, earlier on. And it can even detect small faces, like faces which are further away from the camera. Here is Jess, for example. Of course, the people in the back, it's a little bit too dark, it's a little bit too small. And we get really a wealth of information about those pictures. You see that there is really a lot and lot of JSON that you can then parse in your application. So quite convenient. We have also other demos that you can try. So for example, you can go here a little bit further down in the speech. We have some also a demo, speech to text, text to speech, etc. There is one which I really like. It's the immersive reader. This is a relatively new service that we have. It's in preview. It's going to allow you to make sense of some text. And here is a text. For example, you can enter your own text. And I'm just going to play here what it says. So not just we have the text to speech in that case, but you can also have some text preferences, and you can totally embed this kind of information into your application. We also have some images showing the meaning of some words. So that make reading much more easy, much easier, and much more interesting for young readers, for example. So that could be really, really interesting for your application. All right, so another possibility to try things out is the intelligent kiosk. Now, this is an application that you can install, but most importantly, it is also available on GitHub. So you can go on GitHub, it's a Windows 10 application, and there is a demo gallery. So if you go into there, we're going to try to see here, and this is a video recording, so I look a little bit different right now, but as you can see, this is my face. Right now, I'm happy, so it says, yes, you are happy, that's cool. Now I'm sad. And then a little bit later, I think I will be surprised probably. So basically, you have the possibility to try things out. We have tons of different demos using those. And since this is available on GitHub, you can totally go and check the source code and understand how this is called. So for example, here we have emotion match, and you see that it extracts a picture of a baby who is also happy in that case. So a lot of information, a lot of things that you can try on. And this is quite interesting because we have the source code for that. It's available on GitHub, and the URL for the GitHub repo is available in the slide. Here is how you can configure the key for the services which are going to do the recognition. So this is linked basically with an Azure account. It can totally be a free Azure account if you want. So very, very convenient way to try things out and to make sure that things are working fine. All right, so how do you actually extract things? How do you actually call things from code? Well, there are different ways to do that. One way is to use the REST APIs that we have. And so for that, any service, any application which can call REST services can be used here. So for example, JavaScript, or in that case, .NET. And here we would do an HTTP client. We would set some information. We need the region, and we need the subscription key for the service that we are going to use. And I'm going to show you later where you can get this information. Then we are going to serialize the data, and depending on what service you are going to call, of course, different data is going to be used. So here I'm going to check the sentiment of a text, like is it positive, is it negative, etc. So here I'm going to basically serialize this data to JSON and then turn that into a byte array, which then we are going to send to the service using a post. So here you have the URL of the service. This is text/analytics/version 2.0/sentiment. We send the content and then we wait for the result to come back. The result is going to be some JSON, very similar to what I showed you before. So here is an example of the JSON that we send in the request and an example of the JSON that we get back. Notice that in that case, we have just called the sentiment service, which means that basically we have just the sentiment for those texts. The first text is 92% positive. The second text is 85% positive. So it is quite easy to use. And again, remember that you can chain those services together and say, right now I have extract the sentiment, but now I also want to make sure that the French text is translated to English, for example, as that would be another call to another service. All right, so that's how it works. If you prefer to use an SDK, a software development kit, we can totally do that as well. We have different SDKs for JavaScript, for Java, for .NET, all kinds of things. So here you would go in .NET, for example, create a service client credentials. And again, you need to pass the region in which this service is going to run. You need to get the subscription key as well. And here is a region, and then we create a client which is specific to the service that we will call. Here, in that case, a text analytics client. Now, note that even though we are using the SDK here, under the covers, the SDK is going to use the REST APIs anyway. So it's still the same APIs that you're going to use, and that's going to be quite a little bit more comfortable. Maybe some people prefer to use REST directly. Some other people prefer to use an SDK. It's really up to you. Then we are going to create here to call the sentiment async method. And as you can see, we are passing the same information than we passed before, except that this time we don't serialize it to JSON. We just use a multi-language input, or rather a list of multi-language input. And then we get the information back from the client as a sentiment batch result. So again, it's slightly different, but under the cover, it's calling the same REST APIs than before. And so it is working in the same manner. Okay, so this was an example of basically, trying to call a pre-trained service without refining the training. And for example, in the text to speech, for example, it was just taking the text and it was not doing any customized training. But you also have the possibility to customize training for some of those services. So let me give you an example. Let's imagine that we talked about facial recognition before, where basically it's not going to just match the emotion of a person, but also tell you, I think that this person is Laurent Bugnion in that case. That's one possible example. Another example would be if you have speech to text, for example, where you can train the service with the noise of the room. So you just record a little bit of white noise, and then that's going to improve the recognition. Or another example would be to pass the context in which a text is written, for example, because you know that words have different meaning in different contexts. For example, when I use a word as a software engineer, it doesn't necessarily have exactly the same meaning than if a medical doctor, for example, uses a word in their profession, these kind of things. So here I'm going to show you a demo. And for this demo, we are going to train a custom vision service. And what I'm going to do is that I'm going to go to customvision.ai, which is a portal where you can train a custom vision cognitive service on Azure. And I'm going to create a new project. And I'm going to give some information. Notably, I'm going to give, for example, the domain in which this recognition is going to happen. In our case, we are going to do a fruit recognizer. And so we are going to check the food domain. We are also going to say if that's classification or object detection. Object detection would be image recognition, where it says, well, I think that there is a cup on a table, for example. On the other hand, classification is going to classify in different classes, for example, apple, oranges, bananas, etc. Okay, then we are going to train the model using some pictures. And once we have the training, we are going to publish this as an API, and then our application is going to be able to call the API. So let's see the demo. So for this demo, I'm going to start by going to customvision.ai, all right? And I have actually already created a project. I'm just going to show you how you would create the project. So you go here, you enter a project name, project description, and then you link that project with a resource on Azure, which is basically how the service is going to run. Then you select classification or object detection. You select if you have one tag per image or multiple tags per image. And then the domain, in that case, we are going to do a food recognition because it's a fruit recognizer. All right, as I said, I already created the project, so let's go into that project. And I actually already pre-trained it with apples and oranges. So I already uploaded some images. And as you can see, I have 6 pictures of oranges and 8 pictures of apple. And those pictures are tagged. So basically, I have already added a tag to those images. And then I trained the model, which created an iteration, basically a training iteration. And I published this iteration. So this is available here. You see, I have one iteration, which is published. And I gave a name to this iteration. I was not very original. I gave the name publish, but I could have said this iteration is called Hello World or whatever. So you can have multiple iteration side by side if you want to compare, for example, the training. Now we are going to go and actually use this model in an application. So here I'm using a Xamarin application, which is going to allow me to run this on Android, on iOS, and on Windows 10. I have some XAML. This is the UI. If you're not familiar with XAML, not a problem. Don't worry about it. It's a little bit like HTML if you want. So I have a label. I have an image where I'm going to show the image that I'm taking with the picture. I have a settings button and I have a go button. When the go button is clicked, I'm going to check that I have a prediction key and a project ID. Now, those things are interesting because they are linking me with the projects that I just showed you. So I'm going to go and show you where you can get that. The project ID is going to be in the settings of your custom vision project. All right, this is the project ID that we see here. And as for the prediction key, you are going to link that with a service on Azure. So here I have my cognitive service, custom vision cognitive service, and you can get the keys in the Azure portal directly. So this is where you get this information. Once we have that saved into our application, we are going to create a custom vision prediction client. Now, what is that? Well, it's one of those cognitive services clients. And to have access to that, I added a package in my .NET application via NuGet. In JavaScript, you would do it via npm. So here I have a cognitive services.vision.customvision.prediction. And that's important because you have 2 packages. You have one for prediction and one for training. So basically, you can have an application which is going to refine the training of your model. For example, if you imagine that somebody is on the field and then takes a picture, it says, oh, I don't know what that is, and he can basically enter a description, and that's going to customize the training. Now, because it's a Xamarin application, I also have a media plugin, because since I support Android, iOS, and UWP, I'm going to take pictures, and you don't take picture in exactly the same manner on each one of those platforms. So I need to have here a plugin to abstract the differences. I'm going to set the image to null, so I'm going to hide the image first. Then I'm going to initialize a cross-media plugin, and then I'm going to take the picture. And again, you see that I'm taking the picture in code once, but actually it's going to take the picture in the Android way, in the iOS way, or in the Windows way, depending what platform we are on. I'm going to save that picture. And then once the picture is saved, I'm going to use it to analyze what is on the picture. So I'm going to first show the picture on the UI using this line, and then I'm going to call this method called recognize picture. So let's go into that. Recognize picture is going to use here, it's going to obtain basically a list of prediction model from the service. And to do that, I'm going to get the stream from the picture I just took. I'm going to call classify image async on the client that I created earlier on. And I'm going to pass the project GUID as well as the publish name. Remember, the publish name is the name of the iteration. So if I go back to my iteration here in my cognitive service, here I have published it under the name published. It could be Hello World, it could be iteration 1, it could be whatever. I'm going to give the stream. I'm going to obtain a list of predictions, which I can then order by rank of probability, the probability being between 0 and 1. If I have one tag which has more than 50% probability, it means it's the best tag. And by the way, I will get here 2 tags on every call, 2 answers on every call, because I have apple and orange. So I have 2 tags. So it will tell me, all right, I think that it's an apple at 85%. I think it's an orange at maybe 25%, for example. Let's run the application. So here I'm running on my actual Android phone. I'm mirroring it to my laptop. This is the application. You see the settings are set corresponding to project ID and the resource that I showed you before. Let's take a picture of an apple. All right. This is a beautiful apple. It's sending to the model. Model comes back saying it's an apple at 100%, absolutely clear, no problem here. Let's try again with another fruit. So this time it's an orange, obviously. All right, we send that and we get 99.8% probability that it's an orange. Very good result. Now let's try something a little bit different. Well, this is not an apple, it's not an orange, so what will we get? It should say 0% apple, 0% orange, right? But this is not the way that AI works. Actually, it thinks it's an apple. And the reason why it thinks it's an apple is actually very simple. It is living in a world where you only have apples and oranges. It doesn't even know the concept of banana, okay? So if you have somebody who only knows apple and oranges, it's going to try to please you. It's going to try to give you the best possible answer based on what it knows. And in that case, it says, well, it kind of looks yellowish. I know that there are some yellow apples. It might be an apple because it's definitely not orange. And I know that all oranges are orange, right? So it kind of does this kind of thinking, which is sometimes a little bit confusing for us, especially for developers, because we are not used to these kind of things. But now what we can do is customize the training for that cognitive service. So let's do that. So we are going to go back into our service, all right? And then we are going to upload some pictures of bananas. Let's go to training images, add images, and I prepared pictures of bananas already, so I'm going to go and get them. All right, here we go, fruits, bananas. I'm going to upload all those bananas, and I'm going to tag them with the corresponding name, banana. All right, then we upload this. Okay, it's taking just a few seconds. And now we are going to retrain the model. We are going to create a new iteration with the new data. So we are refining the training. All right, let's do a quick training. Advanced training would be more precise, but would take more time. So in that case, just for the sake of the demo, I'm doing a quick training. It's going quite fast. And then I'm going to unpublish the first iteration. The first iteration in that case is still here, but I'm going to unpublish it and I'm going to replace it with a second iteration using the same name. Like this, I don't need to change anything in my client application. So let's publish that. I'm going to give the name published. I'm going to link that with the resource on Azure that I'm using to do the actual recognition. And now I can go back to my application. Note that the application didn't even stop running. Okay, I'm going to use exactly the same model, but except with a different URL. And now I'm going to take a picture again of the same banana. Let's try. And this time it recognizes it as a banana without any doubt. And so basically I have showed you how you can take an existing service and refine the training by adding more information. But notice that you could also keep the first iteration if you wanted to. You can test directly in the portal, so it's quite convenient. You can also see a history of all the predictions that you made. So it's quite interesting as well. Here, this is for iteration 2. If I go to iteration 1, I see all the predictions that I made. So basically, very nice way to do services. And as you have seen, using that in .NET, it's quite easy using the SDK that you have added via NuGet. It allows you to program that in Xamarin, for example, on Android, iOS, etc. And also, of course, to run in .NET applications. And SDKs are also available for Java, for JavaScript, etc., etc. So really very, very easy to use in your application. All right, so now let's talk about something a little bit different because we have already understood how to use an online model. And we saw that it's quite convenient because it allows me to retrain my model or to customize or to refine the training without having to even restart my application. I don't need to do anything. But using an online model also has some inconveniences. And on the plus side, yes, it's great. You can update your model. You don't need to republish an application. You don't need to do anything. So it's quite convenient. But on the negative side, there is a high latency. And you saw that every time I was taking a picture, I had to wait for a few seconds before I got the result from the service. So it's a little bit difficult, which means that it's also not suitable for videos, because in a video scenario, what you would do is that you would grab a frame from the video, send it to the service, and then until it comes back, it's very, very probable that the frame already changed to another topic. And so it's always going to be out of sync because of that. So it's not very suitable. Another problem is that in order to train my model, I had to upload images in the cloud. Now, the bananas are probably not going to sue me, so I'm okay. But if I have pictures of employees, for example, like think of any firm really, or a bank or an insurance doesn't want to have pictures of their employee in the cloud. They want to keep those pictures on their premises. So in that case, training a model online is not really suitable for privacy reasons or for compliance reasons or for all kinds of reasons. So that can be an issue. Also, it requires an internet connection, and sometimes you don't have an internet connection and you want to run the application on your phone in an offline scenario, things that you are, I don't know, in the wilderness gathering mushroom, and you want to check, is this mushroom actually good or bad? And maybe you don't have an internet connection. It's kind of difficult to try the model in that case. And this is why it can be interesting to export the model for local usage. And I'm going to show you a few options that we have for cognitive services to export those models. So first of all, I want you to know that any model that you put on Azure can easily be Dockerized, or that you create on Azure can easily be Dockerized, containerized, and then after that you can run those containers in any environment that Docker supports. And that can be in the cloud on Azure, for example, in our Azure container instances, ACI, but also our competition supports that, of course. Or you can run that on your own premise. For example, on my own machine, I have Docker running, and I can download the model, put it on Docker, and then it is exposed on my machine in the local host, if you want, as an endpoint. Or even more interesting, you can run those on small devices, what we call edge devices. It can be IoT devices, for example, Raspberry Pi or this kind of thing. It can be drones. DJI actually has drones that are able to run AI models directly on the drone, and then you can send the drone for a mission. So here is an example. Now, this one is a simulation. This small drone is not actually able to run AI model. It's not very powerful, but DJI has big drones that are able to do that. And here, this simulation, we are sending the drone on a mission. You know that drones can fly autonomous mission. And you see on the video screen, it tells you, oh, there is an anomaly here. There is basically a bang in the pipeline, and the drone coupled to the AI model is able to tell you, okay, there is an anomaly. Maybe you should send a team to go and check it out at those particular geographic location. So this is interesting because before, what you had to do is really have a human operator check the video streaming from the drone and decide yes or no there is a problem. Now you don't even need to send the video back to the base. You just send the location where there might be an anomaly. And because those drones are able to fly autonomous mission, you can totally send them on missions like every day at 5 or whatever, and it's going to do the rounds, check the pipeline, come back, recharge, and then the next day it's ready to go again. So it's a very nice way to do that. So again, this small drone cannot run models, but DJI has bigger drones which are able to do that, which are really quite powerful. So this is one way to do that. How would you do to download a cognitive service and run it in a container? Well, there are multiple ways to do that, but this is also supported for a certain number of services that we have. So you can use key phrase extraction, language detection, sentiment analysis, but we also have some in preview. For example, some of the speech services are in preview. Facial API. etc., etc. So you go to a URL. Everything is explained here in this article that my colleague Lance Olson wrote. And you go and you register for the preview, and then a couple of hours or maybe a couple of days later, you get a location where you can go and download the container. Now, this is quite a large download. It's gigabytes of data. I did that for the facial API. It was, I think, 2.5 gigabytes of data, but then you can run it locally. And the advantage is that it's very big, but then it's going to run completely on your machine, and I can train that on my machine without ever leaving my my local machine, for example, for training pictures. Now that's really cool, but 2.5 gigabyte on a small phone, that's not going to cut it. And so you also have the possibility to export a model, a cognitive service model, to a format which is suitable for mobile devices. And in that case, it's not going to be a container, it's going to be the model directly in TensorFlow, in CoreML for iOS, TensorFlow for Android, Onyx for Windows, or you can also export it to a smaller Docker container, which is suitable for running on small devices. And I'm going to show that to you in the demo right now. So let's go to the demo. All right, so if you remember the intelligent kiosk, okay, and if we are running here the real-time crowd insight demo, it is quite slow, okay? So here, this is my smiling face. You see that it's not coming, it's taking basically seconds to arrive, okay, almost 6 seconds. And then after that, if I change, it's taking like 2-3 seconds to recognize. So there is a high latency. Maybe I don't have a good network. Here you see that nothing even happens because the network is very slow. So it's a little bit annoying. And so I want to change that to run locally. So the good thing is that I did download the facial recognition model as a Docker container. I have Docker running on my machine here, the Docker desktop. It's a Windows machine. The container is actually a Linux container, but it doesn't matter. And then I'm going to start this. You see, I do Docker run, and I give it the address of the container and that I downloaded, as well as a few additional information. I'm going to start Docker with this particular service, and then it's going to publish it on localhost on my own machine at port 5000. So now if I go into a web browser and browse localhost at port 5000, I'm going to get some information. It says my Azure Cognitive Service container is running. And if I click on Service API description, this is really cool because we have Swagger description for every API that we have for our Azure services. So here in that case, for this Face Cognitive Service, it is running locally, but it gives me the information on all the REST APIs which are supported here. And that works also for training. So it means that if I want to refine the training of my facial recognition to add, for example, my pictures tagged with my name, Amy's picture tagged with her names, then this data is staying local on my machine. It's never going into the Microsoft Cloud at all. So that's quite convenient. All right, so now that I have the new URL at localhost 5000, I can go into my intelligent kiosk. I'm going to change the settings. Instead of going to Western US for this data, I'm going to change the setting to a custom endpoint, which is running at localhost 5000. Let's go back into the demo gallery. We are going to start the real-time crowd insight. And now we will see that the latency is going to be slower. The first call was a little bit slow anyway, but now we are below 1 second of latency, 800 milliseconds, which makes it suitable for video. And so that's quite cool. You see that I'm very surprised to see how good this is actually running. So that's pretty cool. All right. So now I have, of course, downloaded these gigabytes of data. Again, not suitable for offline running on Android, on iOS, or on even on Windows machine for that matter. It's a little bit big, but definitely not on phones. And so I want to show you that if you have here the cognitive service, in that case, the custom vision, you can also export it to a format suitable for mobile. But here I cannot export this iteration because it has not been trained with a compact domain. So I need to go into the settings. And here you see that I have also food, but I have food compact. And if I take the compact domain, it's going to create a smaller model, which is then suitable for mobile phones. Maybe it's not as precise as a full-blown domain, but it is definitely going to be able to run offline. So that's quite good. So now I selected the compact domain. I go and save the changes. And then if I go back, I need to retrain my model with a new domain. So I select again the quick training. It's going to create a third iteration. The second one, which is the full-blown domain, is still available online. Okay, so that's pretty cool. But now I have a third one, and this third iteration, this time the export button is enabled. So I can go and download it. I have different formats, for example, iOS, TensorFlow for Android, Onyx for Windows, or a small Docker file to run it on, for example, Raspberry Pi, Azure Functions, etc., etc. So here, for example, if I select Onyx and download it, let's do an export. All right, then it's going to allow me to download the file. And by the way, this is not video like a trick or whatever. It is actually fast. Exactly, it is actually running in real time here. So it's quite fast to download this. You see that the download is about 3.5 megabytes. The model itself, uncompressed, is around 5 megabytes. So 5 megabytes is totally okay to run on a mobile phone. And then, of course, it's a little bit more effort than before because it's not using the SDK, the Cognitive Services SDK. It is using directly TensorFlow or CoreML or Onyx. And so you need to code a little bit more in your application to take advantage of those models. But we have some samples online which can help you do that. So here I have extracted the Onyx model. Let's go and take a look at this model. You see that it is 4.9 megabytes. So it is really quite small. And if I open the model, I have here a visualizer for Onyx model, which is called Netron, which is a really cool tool, which allows you to basically take a look at the inside of the Onyx model, taking just a moment to load here. And then it's going to show me the different layers of my model. So that's quite interesting. Etc. So here, in that case, it is in the Onyx format. I could have exactly the same model in TensorFlow or in CoreML and then use it in my mobile applications. So if you want to know more about that, this is where you would know about the Cognitive Services documentation. All right, so this is where we have all the documentation. Notice that we have tons of quick start using C#, using Java, using Node.js, using Python, using even C++, etc., etc. So we have a lot of documentation that you can check and get started with. We also have Microsoft Learn. Microsoft Learn is a fantastic platform where you can learn, like the name says. So you go there, you go with your account. For most of the modules, you don't even need an Azure account. We are going to give you some sandbox where you can try things out. And then the sandbox are going to just be deleted after an hour or custom time, things like that. Here you have the possibility to learn about cognitive services to gain some experience points. It is a great path also to certification if you want to get certified in a specific domain. So definitely make sure to check it out. I have some resources for you. First of all, on the right-hand side of this slide, you see there is a URL, there is a QR code. If you scan that with your phone, it will direct you to a web page on my website, and there you will get the slides, the links to the repos that I have showed you that I have used in this presentation, notably the custom vision client. On the left-hand side, you also have different information about cognitive services. The location for the repo for the intelligent kiosk is there on GitHub, and so you can go and check the code, as well as the custom vision client repos, Xamarin application that I just showed you. If you want to get started with all that, you have the possibility to create a free account on Azure at this URL on the left-hand side. If you are working with students, we have also a lot of resources for education. Make sure to check it out. You can also create free Azure accounts for all your classes, for example, in a very easy manner. Hopefully, this presentation was helpful for you. I hope you liked it. My name is Laurent Bugnion. I'm a Microsoft Cloud Advocate, and I will be happy to answer the questions if you have some on the chat. Amy, back to you, I think.
Fabulous. Thank you, Laurent. That was brilliant. Those demos really showed everything end to end. There is a couple of questions in the chat that we'll ask you, and there's also a couple of questions that myself and Sammy also have. So we will take this time, if we can, to get them answered. One of the interesting ones was from an audience member. It's quite a broad one, so I gave a very quick answer on what I thought it meant, but I'd be interested, Laurent, in hearing your perception. So the question was, can you please explain what does cognitive mean in terms of AI or machine learning, so that they had a better understanding of the whole session. So yeah, what does cognitive mean to you, Laurent?
Yeah, it's interesting. What is in the name, right? And you know that names are hard and it's always difficult. And cognitive has to do with cognition, right? So it has to do with conscience and with intelligence at certain level, right? In my opinion, and I was not privy to the reasons why this name was chosen for that particular thing, but I think that what they wanted to have a name for services which have to do with intelligence, but at the same time without using the word intelligence, because artificial intelligence is such a broad domain, right? And so I imagine that it's the reason why they did that. Cognitive services, the way that we use them and that we use this term in Microsoft and in Azure specifically mean it is basically services which make usage of artificial intelligence in a way or another in the background, but without you having to understand all the difficulties and all the the intricacies of artificial intelligence. So basically, it's a little bit of an abstraction on top of artificial model. Of artificial intelligence models, if you want. I hope that it clarifies a little bit. Now, why they chose the name Cognitive Services, I was not in the discussion that particular day, so I cannot tell you. I think it's actually a pretty cool name. I do like it. I know that Microsoft has a reputation of being horrible with names, but I think that in that particular case, Azure and Cognitive Services, they did kind of a good job because it says what it is, but at the same time, it's also a name which is quite original, I think.
Well, I guess that's the same reason why they switched the name from Azure Search to Cognitive Search, to bring it all a bit more together.
That is, of course, a thing where when a name is popular, see Azure, for example, we tend to slap it on everything. And, you can find it's good or it's not so good. It depends a little bit. Sometimes it's a little bit confusing. But yeah, it happened. Yeah, when they have a cool name, they like to use it for sure.
Yeah. Well, Laurent, I was also wondering, when you build a custom vision model and you download the model to use on the edge or on-prem, does it mean you have like a free model that you can just reuse everywhere, or how is it built?
Oh, this is a fantastic question. And I want to thank you so much because I actually didn't mention that. So the way it works is like that. If you use a cognitive service that you export as a Docker container, in that case, you are still going to be billed for the usage. And that is interesting because I don't know if you may have not noticed that, but when I started my Docker instance, I actually entered the URL for the billing. And it is one of the parameters of my Docker container. And it said, okay, where do I get billed? And so what is going to happen under the cover is that we are going to bill you for on demand, right? So how much consumption you use of the service. There is a very generous free tier, which means that up to a certain number of calls, we are not going to bill you anything. But if you consume more than that limit, then we are going to start billing you because, believe it or not, I have kids and they need to eat. And so we need at some point to get a little bit of money. But really, if you use those services more than a certain limit, it means that you start also making money of that, most probably, right? So that's the way it works. So this model, which is running on Docker, can be offline for half an hour. And after half an hour, so basically every 30 minutes, we are basically pinging the service, the billing service, and then it's going to say, hey, I have been used so many times, you need to add that to that person's subscription. Now that is for the Docker container. If you download from the customvision.ai, if you download the TensorFlow, the Core ML or the Onyx model, now those are free to use, but of course they are very much smaller, they are less precise, but those you can use them on your Android phone, on your Windows machine or whatever, on the edge without being built. So those are free to use, yes.
Okay, cool. I didn't know that. So it's the good way then is that you don't need a very stable internet connection on that device because it's only connecting once in a while.
Correct. Yeah. So in the case of the Docker container, we only send billing information every half an hour. If you run it for longer than half an hour, at some point it's going to stop working and tell you, sorry, but I cannot reach that particular endpoint. And then it's going to stop working, yes.
Okay, seems reasonable.
Yeah.
Can you tell us about any project that used cognitive services that in a way that you never thought about? Like, okay, never you thought about using that API or this this service in this different way?
Well, you put me a little bit under the spot here. So one thing that I really like in cognitive services is that sometimes they kind of illustrate the fact that AI is used in a way that you didn't necessarily think about, like the immersive reader that I was showing, or the form extractor, for example. I know that Amy is very familiar with this demo, right? The form extraction. It's quite interesting because those are use cases that I never really thought about. Like the forms extractor is interesting. You basically say, you point to a folder with a bunch of PDF files, and then it's going to be able to extract information from this PDF file. And you can kind of train it to say, well, okay, probably in this area, it's rather going to be the address. In this area, it's rather going to be, to whom it may concern or whatever, or these kind of things. And then it's able to extract the information and put it in tables or in JSON files, so that later it's way easier to consume. And I think those are domains where, if it was me, because I'm a software developer, I would rather go brute force on it, right? I would say, hey, let's just go and do a big if then else and say, all right, if I have an address here, I'm going to extract it. But you can imagine that it's very time consuming, right? So the idea of using a cognitive service to do this kind of thing is actually pretty cool. And it's kind of taking advantage of the artificial intelligence that we have, right? But I didn't necessarily think about it as a developer. It didn't necessarily come to my mind to actually use that. So I think those are examples which are pretty cool. If you check the list that we have also in the search, for example, we have search, yes, and search is not necessarily an AI thing, but then we also have intelligent search, and then it's going to be able to say, well, I'm going to search, but maybe in the context of a specific domain model, like software engineering or medicine or whatever, and so, yeah, those are really some cool applications.
Okay, thank you for your answers.
Amazing. Well, Laurent, I think we are up to time, unfortunately, but that was, thank you so much for sharing all that information with us, answering all our sort of ad hoc questions as well afterwards. It's been an absolute pleasure to have you on the stream. So yeah, thank you for joining us.
Absolutely, it was such a pleasure. So hopefully you have a very good time and try to, a lot of courage for the 8 hours. You still have 8 hours? Did I hear that right?
Yes, yeah, I've got a little bit of a break after this session, so that's always
nice.
a treat.
All right, very cool. All right, everybody stay safe. Thank you so much for having me. It was a pleasure.
Thank you for being with us, Laurent.